Welcome to a basic arc length example. So recall, for continuous and differentiable f, on the closed interval AB, arc length was equal to the definite integral from a to b of the square root of 1 plus f prime of x, that f prime of x in parentheses squared dx. So for example, let's find the arc length of the curve given by y equals x squared between x equals 0 and 5. So just in terms of the picture, we are looking at y equals x squared. We're looking from x equals 0 to x equals 5. So essentially, we are just looking at the curve running between those two values. So our f of x is x squared. That means that our f prime of x is 2x. Our a is 0, our b is 5. So we have that our arc length is equal to the definite interval from 0 to 5 of the square root of 1 plus the 2x is then squared dx. So we are looking at the definite integral from 0 to 5 of the square root of 1 plus 4x squared dx, if you want to view it that way. This integral lends itself well to trig substitution. So if we go ahead and run trig substitution, drawing our triangle, that square root of 1 plus 4x squared would be our hypotenuse. 4x squared is 2x in parentheses squared, so we will do our opposite as 2x, and adjacent is that 1. This gives us then that tangent of theta is 2x, or x is 1/2 tangent of theta. We therefore have that dx is 1/2 secant squared theta, d theta. We similarly have the secant of theta is equal to the square root of 1 plus 4x squared over 1, or just square root of 1 plus 4x squared. So we are looking at the integral of square root of 1 plus 4x squared dx. This is the same thing as the integral of secant of theta times 1/2 secant squared theta d theta. So we are looking at 1/2 times the integral of secant cubed theta d theta. Secant cubed is one that we know. So we have 1/2 times, we have 1/2 secant theta tangent theta plus 1/2 times the natural log of the absolute value of secant of theta plus tangent of theta. Or in other words, we have 1/4 times secant theta tangent theta plus 1/4 times the natural log of the absolute value of secant theta plus tangent of theta. And of course, we technically have our plus c. Plugging back in, secant of theta was the square root of 1 plus 4x squared. And tangent of theta was simply 2x. So we are looking at our integral is equal to, so our integral of the square root of 1 plus 4x squared dx is equal to 1/4 times the square root of 1 plus 4x squared times 2x plus 1/4 times the natural log of the absolute value of the square root of 1 plus 4x squared plus 2x, and then plus c. So we have, therefore, that our definite integral from 0 to 5 of the square root of 1 plus 4x squared dx is equal to, we have 1/4 times 2x would be 1/2 times x times the square root of 1 plus 4x squared plus 1/4 times the natural log of the absolute value of the square root of 1 plus 4x squared plus 2x and absolute value. We are evaluating at 0 and 5. So plugging in 5 first, we have 5/2 times the square root of 1 plus 4 times 5 squared is 101. Then we have plus 1/4 times the natural log of the absolute value of the square root of 101. Then plus 2 times 5 would be plus 10. We are subtracting off, we get a 0 from the first piece. Then we would have 1/4 times the natural log of the absolute value of the square root of 1 plus 4 times 0 squared is just 1. And then we would have plus 0 also inside of our natural log. Natural log of 1 is simply 0. And so we are just left with our area is our arc length is 5/2 times the square root of 101 plus 1/4 times the natural log of the absolute value of the square root of 101 plus 10 and the absolute value. So this is our arc length. Often we want to give it in decimal form instead. So if we go ahead and put this into our calculator, we wind up getting the arc length is approximately 25.87 units, whatever units we're working in. So again, this is how we can go about finding arc length by creating this definite integral and evaluating the definite integral. In the next video, we will go ahead and take a look at an example where the integral is not so easy to take, in which case we will do some numerical approximation.